In JavaScript, there are also some important built-in objects you may use. And in this lecture, I'll have a look at the math object. So the math object gives us access to some built-in properties or functions connected to the topic of mathematics. So if I create a new variable here, for example, and I call it pi, and as you might be aware, this is something like 3.14 and so on. But probably you don't know it by heart, and maybe you need more decimal places than just the first two. So a great way to get access to pi is to use the math object and then the pi property. And now if I log pi to the console, what do you think we'll get? Well, we get pi with a lot more decimal places than just the first two. The same is there for e. So if we log this, well, we got e. So we got these very important mathematical symbols built in and available with the built-in math object, which you may use like this. We not only got some built-in properties or important math symbols, we also got some useful functions or methods which we can use. For example, imagine we have a, which is -3, and we wanted to get the absolute value of it. Well, we could use the abs method and just pass a. Now, what do you think will happen if I hit run? Well, of course we get 3, so the absolute value, ignoring the minus sign here, just the distance to 0. We also could have a value, a floating point number, and we could call round. If I now hit run, of course we get 1. We also have math ceil. What do you think this function does? What do you think will happen if I hit run? I get 2. This function always rounds the number, but it always rounds it up to the next full integer, so 2 in this case. On the other hand, we also have floor, which would, if we have 199, still give us 1. So this function always rounds the number down to the closest integer. We also can do some exponential calculations by using the exp method and passing 2. Well, I'm not asking what we'll get, but we get this. So this is e to the power of a, which is 2 in this case. E of the power of 2. E of the power of 2 then, therefore. We also might use the logarithm, by default the natural logarithm here. And if I again use e here, and notice, of course, that this has to be a capital E. And now I hit run. Now I'm asking, what will we see in the console? Because this is solvable in the head. Well, we get 1 because the natural logarithm of E is 1. You learned that in math, didn't you? So these are some built-in useful functions. Now there are some more useful functions. For example, the max function, where I just pass a list of arguments, and this list may be as long as I need it. And now what do you think we'll get if I hit run? I think it shouldn't be too difficult. Well, I get 1000, so the highest possible value. And of course I also have min, which unsurprisingly will give me 1 here. We also have, and this is an important one, math random. Now what do you think we'll get here? Well, hard to guess, but we get a random number, and the random number will be, and that's important to understand, between 0 and 1, and as you can see, it also uses or is a floating point number. And random numbers are of course something you'll often need in applications, because a lot of applications use some kind of random effects. You might have a lottery application or a quiz, or whatever. Oftentimes you'll need a random number, but oftentimes you also need a random number which is not between 0 and 1 and using floating point numbers, but for example between 1 and 10 or 1 and 100. How could you generate such a number? Well, math random only gives you this kind of number, but it's easy to transform it. I'll create a new variable called random, and I'll generate a random number here, but then I'll multiply that with 100 if I want to have a number between 1 and 100. Because now, if I log this, you'll see that we get higher numbers. So numbers between 0 and 100, or specifically 0 and 99.99999. So 100 would be excluded. However, I want them to be including 100, and I also want to have them from 1 to 100, not 0 to 99.99999. In order to do this, I'll add +1. This makes sure that I start at 1, not at 0, because I'm adding 1 to the possible smallest number, which is 0. And I also go up to 100.99999 as the highest number. Now I also don't want that. So we're almost there, but I don't want to have 100.999, the highest number, and I also don't want floating numbers. So now I can use math floor on the expression where I multiply it with 100 to make sure that I only get integers and that the highest possible number is 100, because 100.99999 would get rounded down to 100. And of course, 0.99999 would also get rounded down to 0, but since I add +1, I start at 1. And here, of course, just to make sure that you understand it, 100 is excluded by default, or the highest number is excluded. Therefore, the highest possible number here would be 99.99999. I round it down to 99, add 1, so 100 is the highest possible. So now if I hit clear and then run it, well, we got 100 right away, but we also get a lot of other numbers, as you see. So this is how you can play around with that. And here you see that we're using two different math functions, as well with some logical thinking, to generate the range of numbers we want to have for our random number. And as already mentioned, random numbers are probably something you'll often use in your application.